today we're going to talk about fault trees. Fault trees are a way to graphically represent risk. It's one of the tools that we're going to study. And remember when we talked about deductive and inductive tools for evaluating risk? An inductive tool looks at the various components of a system and examines each for its ability to result in a failure of the whole system. Now, a fault tree goes in kind of the opposite direction. A fault tree looks at risk from, say, the catastrophic level. It starts with failure of the system and reasons down to the various factors that singly or together could cause the failure of that system. So what we're going to do is draw a graph to represent our thinking. And you know, of course, from your own studies that a graph is much more effective in allowing us to reason something quickly than to read a paragraph. So that's why we use it. Now, it originated in 1962 at Bell Laboratories, and it combines interactive events. And we can do two things. Once we draw this fault tree, we can analyze it qualitatively. Qualitatively means we use our reasoning to look at the fault tree. And in more advanced systems, we can use it quantitatively. It's very exciting. I don't think we'll have time to do it in the class at this point, but quantitative analysis is where you actually do mathematical calculations to arrive at the failure rate of a whole system. So this is a very useful tool, a fault tree. Now, of course, it does have some limitations. I'll want you, of course, to know these limitations. And sometimes we fail to include certain events that need to be in the fault tree because of inexperience or oversight. And sometimes, particularly quantitatively, we might not exactly know the frequencies of various events. It's also a fairly costly process to do a fault tree in a more sophisticated form. I also want you to keep in mind that fault trees can be used to describe an accident sequence. In other words, after an accident has occurred, you can use a fault tree to describe the various factors that might have caused that incident. So let's talk about fault tree symbols. They are called events. There are 4 basic event symbols. Now, all fault trees begin with this symbol at the very top. This symbolizes the event itself that we're going to analyze. Anything that we analyze begins with a rectangle. So a rectangle is always at the top of a fault tree, and then the various sub-events, if we're going to analyze those sub-events, they're going to be rectangles too, and I'll show you how it works. Now, a basic event is our next one. That's a circle. A basic event often describes a human condition, like maybe the worker is sick, maybe they're on drugs, something like that. So a basic event usually describes something that we really don't need to analyze further. Normal events are kind of off-on events. We're probably not going to use those in our example today, but a lot of fault trees have to do with electrical systems. And a normal event is for switches to click off and on. Now, an undeveloped event is what we will find at the end of our fault tree sequence. An undeveloped event indicates that there is an event that we may want to analyze later or could be analyzed. A basic event, we really are not going to analyze that further, and it really wouldn't help us if we did. Undeveloped event gives us an opportunity to think later about how we might expand our fault tree. All right, so here's your description down here. Undeveloped events, basic events, fault events. All right, so we have fault tree symbols. Now, we have another two symbols that we use to combine all of these, and these are called logic gates. Now, an AND gate is our first symbol, and as you can see, it's just this thing with a flat bottom like that. An OR gate can be similar, but it has a cup kind of at the bottom. AND gates and OR gates tie all these events together. Sometimes an accident can be caused by two events combining together, and for that we would use, of course, an AND gate. Sometimes one thing or another thing could cause an event, and that would be an OR gate. Now, interestingly enough, all of these can be quantified. Very, very useful tool. Again, we're not going to do that today, but keep in mind that there are qualitative and quantitative analysis that can be done with fault trees. Now, this is an example of a completed fault tree. I just wanted to show you this. We're going to actually do one together, but this is kind of the way it looks. It has funky little lines, but hopefully you recognize the symbols from our discussion. All right, so let's go ahead and see if we can do one together. All right, here is our setup. You have an industrial conveyor machine. The hydraulic system on the conveyor machine is vital to worker safety. If it fails, and that means the whole conveyor machine, the results could be catastrophic. So, this is the description of how it might fail. The hydraulic system could fail in two ways. The starter switch could fail, or the braking mechanism could fail. So here we have two separate ways that it could fail. They're not tied together. One is the starter switch could fail, and the other is the braking mechanism could fail. All right, so now let's look at each of these components. The starter switch could fail if the circuit overloads and the circuit breaker fails. So we're talking now about the starter switch, and it could fail in two ways, but these two events, the circuit overload and the circuit breaker, those both have to fail together. Okay, now let's look at the braking mechanism. The braking mechanism could fail due to human error or from a broken brake joint. Okay, so we have these two things, and one is separate from the other. So the braking mechanism could fail due to human error or from a broken brake joint. All right, now we're going to analyze a little bit further. We're going to analyze the human error part. Human error could occur if the operator is drunk and his backup operator is not available. So we have two main components, two reasons that the hydraulic system could fail, but we also have analyzed those two components. So let's have some fun and draw this thing. All right, class, we've looked at our example, and now I have drawn it for you. And here it is right here, the hydraulic failure. Here's the example in a fault tree that we have drawn. Now we started with the hydraulic failure up here. And again, that's in a rectangle because that's how we start our fault tree. And the second thing that we learn is that there are two major ways in which it could fail. And they are basically separate from each other, and that's the starter switch and the braking failure. And so we use this little OR gate right here to say either this could happen or this could happen. Now obviously it's simplified for discussion purposes, but what this says is that this could fail or this could fail, and they're separate. They don't have to act together to cause the failure. But we have a rectangle for each of these events because we're going to look at them further. So the next thing, let's look at the starter switch and how I described it over here, could fail in two ways. The circuit overloads and the circuit breaker fails. Now these two events must both occur to result in failure. So the little gate that we have to describe the event here is an AND gate. So the circuit overloads and the circuit breaker fails. So down here we have these two little diamonds. Now at the end of a fault tree, you're probably going to have either diamonds or circles. Diamonds mean that you may want to look at this further and see, for example, why the circuit would overload or why the circuit breaker might fail. So use the diamond to say, well, I need to look at that later. All right, so we've kind of taken all the information that we have on starter switch failure. The other one is the breaking failure. And it says from our example over here that human error or a broken brake joint could cause failure. Now these events are independent of each other, so we use the OR gate over here. So human error could occur, or there could be a broken brake joint. So we again represent the broken brake joint because we may want to look at that later. We may want to try and figure out what could cause a broken brake joint. Now, human error, we're going to look at that right now. And I showed you over here, human error could occur if the operator is drunk and his backup operator is not available. So this guy right here, he's a mess. Okay, this is and the operator is drunk and the backup is not available. Both of these events have to occur to cause a failure. So they occur together and we use an AND gate. Now, down here we have two circles instead of two diamonds. And a lot of times we use circles to represent a human condition or event. And we're really not going to analyze. We're not going to take this guy to a psychiatrist to figure out why he gets drunk, for example. And again, we're not going to necessarily figure out why the backup is not available. That really wouldn't help us in terms of our risk. So we use a circle to indicate that no further analysis will be done. And here's our circle on both of these. Okay, so our broken brake joint is the other reason that the braking failure could occur. And again, we use a diamond to represent the fact that we may go back and look at that. All right, so you see how we've connected everything together with our AND and our OR gates. Again, any time that you're going to analyze an event further, you must have a rectangle. At the end of your fault tree, at the branches end of your fault tree, you're going to either have diamonds or circles. If you can look here that we've done that. Now, generally, we use, just as a convention, we use these lines to connect everything together. We don't have diagonal lines, we have straight lines. They're either horizontal or vertical, and those connect everything together. So, are you ready to try it on your own? You can always listen to this video again, watch what I did, or email me if you don't understand it, but I have an assignment for you that you can build your own fault tree. So I will let you do that now. Good luck.